Hey, how's it going, everybody? Today in this video, we're going to take a look at coefficient of restitution, which is talking about the velocities with which the objects in a collision leave each other, divided by the velocities at which they approach each other. So that equation that we got was E equals V for object B final minus V for object A final divided by V for object A initially minus V for object B initially. So this works for any collision if we know enough information about them, where E is going to be 1 for elastic and E equals 0 for inelastic completely. And anything in between is going to be inelastic as well. But really, mostly what this equation is going to be useful for is the elastic situations where it is perfectly elastic and energy is conserved. So in a situation like that, let's talk about where we can get the fact that E is equal to 1, which is equal to this equation, from our conservation of momentum and conservation of energy equations. So let's start off with conservation of momentum to begin with. Conservation of momentum is momentum of object A plus momentum of object B initially is equal to momentum of object A after the collision plus momentum of object B after the collision, which momentum here is mass times velocity, as it usually is. So with this, what I want to do is get object B on the same side as object B and object A on the same side as object A. So I am going to take this and algebraically move it to the other side and do the same thing with the other A value and bring that over to the other side. So this is going to give me MB VB minus VB prime when I pull out the mass, and MA VA prime minus VA on the opposite side of the equation. And then I'm going to do the same thing for conservation of energy in this case, and take my conservation of energy formula, 1/2 MA VA squared plus 1/2 MB VB squared is equal to 1/2 MA VA prime squared plus 1/2 MB VB prime squared. So in the same way that I moved the B's over to the same side and moved the A's over to the same side, I'm going to do the same thing with this, pull out the masses one more time, and get a second formula. So B's are moving over to the other side, and A's are moving over to the other side. And one other thing that I'm going to do here, since there's a 1/2 on each of these, I can divide out that 1/2, dividing the whole thing by 1/2 to get rid of it. So what that's going to look like then is MB parentheses VB squared minus VB prime squared, and that's equal to MA VA prime squared minus VA squared. So now what I have here, VB squared minus VB prime squared and VA prime squared minus VA squared, we can use the mathematical identity dot difference of two squares to factor these two things. So when I factor that, that's going to be MB VB minus VB prime VB plus VB prime. And that's equal to MA, factoring with difference of two squares again, is VA prime minus VA and VA prime plus VA. Okay, so here's where we're going to take the two equations and divide them together. Remember, algebraically, if you want to divide one side of an equation by one thing, you have to divide the other side of the equation by something equivalent in order for it to still be an equality. So if I want to divide the left side of this equation by something to get rid of the VB minus VB prime, I would have to divide the other side of the equation by something equivalent. So since I have two equivalents here, let's call this like 1 and 2. Or really, instead of numbers, we'll call this x and we'll call this y. If x and y are the same, then I can divide this side by x, divide this side by y. And it still shouldn't change the fact that this is a mathematical equivalent. So let's go ahead and divide the left side by x, which is the MB VB minus VB prime. And then divide the right side by y, MA VA prime minus VA. And so we can cancel MB and MB. We can cancel VB minus VB prime. We can cancel MA and VA prime minus VA. So that the equivalency that we're left with is VB, let me center that, is VB plus VB prime equals VA prime plus VA. And now I'm just going to rearrange this around to bring the final velocities to the same side and the initial velocities to the same side. So algebraically, I'm going to subtract VA prime from both sides and subtract VB from both sides. So the VA primes here cancel out, the VB primes here cancel out, and leave us with VB prime minus VA prime equals VA minus VB. And then since our coefficient of restitution equation is in terms of a ratio, I divide both sides by VA minus VB. And the final equation that I come up with, VA minus VB over VA minus VB, is 1. And I have VB prime minus VA prime over VA minus VB, which is the same thing as our coefficient of restitution equation when it's an elastic collision where E is equal to 1 and energy is conserved. So again, this is a really helpful equation, guys. I want you to know this, especially if you're going to take the AP test. This is not an equation that is on the AP sheet. It's something that you might want to memorize just for yourself. So this is just kind of showing you guys where this comes from. We didn't just pull it out of nowhere. It is really just a combination of those two equations. And this one makes it a little bit easier when you're doing a system of equation in an elastic situation. Hope this helped, guys. Have a nice day. I'll see you later.